Okay, so chapter 12 is problem solving and creativity. So when we think about a problem is an obstacle, something that is in the way of us accomplishing some type of goal we want to accomplish. A problem may not always be immediately obvious to us how we should solve it or get around it. It's something that's oftentimes difficult for us to solve, so it takes some thought to figure out the best way to handle it. So there's lots of different theories and approaches to solving problems. One of them, which is the Gestalt approach, is the idea that when we have a problem, we have to represent that problem in our mind. So we have to reconstruct or restructure how we view the problem. And an example of that is Kohler's circle problem. And if you look at the figure, you can see a picture of a crossword puzzle that's shown on a page, but there are also clues for filling in the horizontal and vertical words, which would be a way to solve a problem. So whenever people have crossword puzzles, they're able to use those clues to come to the solution. Insight is another way to solve problems. This is when you come to a sudden realization of the problem solution. It kind of just comes to you. But again, it requires restructuring of the problem and looking at it in a different way. So there's been lots of research around insight as well, such as the triangle problem and the chain problem. And if you look at these two things, and it's like, okay, well, how do you make this work? How do you create one single line, one single stroke? How can you unravel these things? And you have to just view it in a different way. And your textbook will show you the solutions to those problems. We also can have some obstacles. One obstacle to solving problems is a term called functional fixedness. And this is the idea that sometimes we get stuck in a certain mindset and we have difficulty viewing the problem in a different way. These are things like the candle problem and the two string problem. The candle problem is when we see boxes as containers, and we don't realize that boxes don't just have to be used as containers for things. We also can use them as support beams. And then the two string problem, this is the idea of if we needed to connect these two strings, as you see on the pictures together, what is the best way for us to do it? And if we only think we can reach and tie them together, and we never think about the fact that there's a chair, that there's some pliers, and maybe we can use those items to help us connect the strings. So functional fixedness is when we just kind of get stuck in one particular mindset. The mental set is how we approach problems. We tend to approach problems from the same mental set. If we think one thing works, we tend to continue to solve similar problems that way because it's worked for us in the past. This is an example of the water jug problem, which is when people have a certain mental set and it prevents them from thinking of a simpler solution. And you can find that water jug problem in your textbook. The information processing approach tells us that when we have a problem, we have to think of the initial state of the problem, intermediate states, and then also the goal state. The Tower of Hanoi problem was an information processing approach where the operators use rules that specify which moves are allowed and which moves are not allowed. And then they reduce differences between the initial and goal states and then create intermediate states that help the person completing the problem reach their goal. We've also got the mutilated checkerboard problem, and this is the idea that parts of the checkerboard aren't there, and how can you solve the problem to create it the correct way. These conditions differ in how much information is provided about the squares, and it's easier to solve when information is provided that points toward the correct representation of the problem. The think aloud protocol is when a person says something out loud, says something they're thinking out loud, and that can kind of shift how they view a problem. So it's almost as when you talk to yourself, you're able to process it more by getting it out and hearing it and realizing that that doesn't work. Using a solution to a similar problem can also guide a solution to a new problem, such as the Russian marriage problem and the mutilated checkerboard problem. You can have analogical transfer, which is the transfer of one problem to another. We can also use analogies to solve problems. And that's when you notice the relationship between two things and you're able to map correspondence between the source and the target. These analogies can aid in problem solving and also offer hints of something else that should be noticed. There could be surface features that get in the way. There could also be structural features that play a role in understanding of the analogy. For analogical encoding, this is a process by which two problems are compared and similarities between them are determined, such as the trade-off strategy, which is, I'll give you an A if you give me a B. Those are kind of ways people negotiate with each other. And then the contingency strategy, which says a person gets what they want if something else happens. An analogical paradox can be difficult to apply to analogies, but people routinely use analogies in real world settings. The in vivo problem solving research has shown us that people are observed to determine how they solve problems in the real world. So, an advantage of having in vivo problem solving research is that it's naturalistic in its setting. So, we get to see people in their natural environment. One of the disadvantages of that is that it can be time consuming and we really can't isolate and control the variables. We can't really manipulate anything because it's all naturalistic. So when experts need to solve problems, they do so in different ways. So, an expert is going to be a person who, by devoting a large amount of time to learning about a field and practicing and applying that learning, have become acknowledged as being extremely knowledgeable or skilled in that field. So, when you've worked with and kind of explored ideas for a while, you can become an expert. So, experts solve problems in their field more quickly and with a higher rate of success than any beginners, and that's simply because of their experience in the field. They have more knowledge about the field, therefore, they have more ways that they can approach a problem. They also spend more time analyzing a problem. It's not that they're better than new people who are newer in the field. They just spend more time on it and they've had more experience to it. They're also less likely to be open to new ways of looking at problems because they've probably already gone through trial and error. They've probably already figured out those other ways don't work. Their knowledge is often organized so it can be assessed when needed to work on a problem. Somebody who is novice may only look at surface features, and somebody who's expert is going to look more at structural features. We also have to consider creativity when it comes to problem solving. Creative cognition is a technique to train people to think more creatively. Can involve pre-inventive forms, which are ideas that precede creation of a finished creative product. And it can also involve innovative thinking, coming up with novel ideas, making new connections between existing ideas, and engaging in divergent thinking, which is that open-minded brainstorming, considering a lot of different possible solutions. When it comes to the brain and how it develops in terms of creativity, Chai and Snyder in 2012 said that a deactivated left anterior temporal lobe causes people to think outside the box, especially in something called the 9-dot problem, where those dots are there and they all need to be connected. And then in 2006, there was the Prepared Mind study, which used EEGs on the compound remote association problem, which showed that the frontal lobe activity increased right before a person has insightful solutions, and the occipital lobe increases before non-insightful solutions. So if we really think about that frontal lobe with the executive functioning, that makes sense that with insight, it activates, and the occipital lobe has more increased activity when non-insightful solutions are there, because your occipital lobe is controlling your visual senses and how you see something. Default mode network is an idea that with incubation, we can get ideas after taking a time out from working on a problem. So that's like when we take a break and we, maybe go to sleep or we do something else and we come back to the problem later and we're then able to see it with clearer eyes. So there are certain regions of the default mode network and the executive control network that are strongly activated during idea evaluation rather than idea generation. That was found in a research study in 2012. We also have noted from researchers that creative thinking is just different thinking. In 2015, participants suggested an alternative use of an object and that higher originality ratings associated with higher activity of structures in the default mode network. Daydreaming involves purposeful mind wandering, and daydreaming oftentimes serves a purpose for us. When it comes to solitude, this is when we avoid things that are distracting. We give the mind space and time to make new connections and find meaning. We can also have mindfulness, which is focused attention, meditation, when we're able to focus on one thing, such as our breath, and then return to it when we're distracted. We also can have open monitoring meditation, which is when we pay attention to whatever comes up and we follow it up until the next thing occurs. So hopefully this information helps you understand a little bit more about problem solving and how the brain processes the issues we encounter.